Okay, so let's start now. And today we'll discuss unsupervised learning algorithm. So far we have studied supervised. So today we will discuss one unsupervised algorithm as well. Okay, so let me just open smooth draw. Yeah, this one. Sorry, come here. Yeah, this one. Fine. Okay, and very famous supervised unsupervised algorithm. Remember, we are going to discuss is unsupervised machine learning algorithm. Okay, and when it is unsupervised, only inputs will be given to you. Okay, only inputs, no outputs or no labels or no targets. Okay, nothing will be given to you, no supervision will be there, so only and only input attributes will be given to you. Okay, and somehow you have to find the pattern among the data. And very famous unsupervised algorithm which is available is K means clustering algorithm. Very famous. Okay, K means clustering algorithm. And how it works, let's see that. Very simple logic. Suppose I have two attributes, x1 and x2. Okay, this is x2, this is x1. Okay, some data points are giving here, example like this. Okay, some data points are giving here, like suppose. Okay, so how it starts, understand. First of all, we have to pass a parameter here. Okay, that parameter actually is known as how many clusters we want to form. Okay, how many clusters means number of clusters that we are specifying this case. So this case we have to specify. Okay, how many clusters I want to form, actually number of clusters I want to form. And you will say, sir, how I will come to know what many clusters I want to, which cluster is optimal for me. Normally, if you go, for example, I have a picture available with me, right? In which several people are there. Not people, suppose there is an image available in which only cars I want to identify. Okay, other thing I don't want to identify. Only car should be recognized and other thing should be treated as a background only. Okay, so how many clusters I have to mention? I have to mention two clusters, one for the car and second for other background. Okay, similarly, there is a car in which a horse is there, dog is there. So I want to identify horse and dog. Okay, not other things. So horse and dog horse will become one cluster, dogs will become second cluster, and background will become third cluster. So while looking at the data, we may recognize how many clusters are there, but sometimes some data will be given to you in which you are not knowing how many clusters can be formed. Okay, in that scenario, actually we have to use some method known as elbow method, and that elbow method will tell me which is the best cluster for this. What is the best? Suppose some text data, if image is given to you, from the image you can recognize easily, okay, this much, this is the horse I want, this is the dog I want, or this is the car I want, this is the human I want. That can be done. Okay, but when a text data will be given to you, it will be difficult for you to identify, right? In that scenario, actually, you have to find a optimal value of clusters. How many clusters I should select? Okay, that we will discuss. For that purpose, we have to use the elbow method. How the elbow method will work, we will see that. Okay, but suppose I specify example. I need k is equal to 2. I need k is equal to 2. So what k means does, randomly, understand everyone, randomly along x1 and x2, any 2 points it will create, known as centroids. Any two, anywhere, doesn't matter, they can be anywhere. All 2 points can be here, or both the 2 points can be here, or 1 point can be here, 1 point can be here. Anywhere randomly it picks. Any 2 points. Suppose it pick 1 point here. Let's say this is your point. Okay. And second point it pick here. Anywhere it can pick, randomly. Okay. So two centroid, because you mentioned k is equal to 2. So it will means I want to form two clusters. So randomly it will pick two clusters anywhere in the x1, along the x1 and x2. Any 2 points. Now what it will do, everyone? It will compute the distance of every point. How many points are there? 1, 2, 3, 4, 5, 6, 7, 8. Distance of every point with centroid 1. Suppose this is C1. So distance of every point with C1. Similarly, distance of every point with C2. Right? It will compute the distance of every point with the C1 and every point with the C2. Then after calculating the distance, it will find out that, okay, this point this point. Okay, this point is nearer to C1 because we find out the distance. So after distance coming to knowing the distance come out across, this point is nearer to C1 in comparison to this 2. So it will say this X1 belongs to this C1 cluster. Okay, find out the distance of this point along with again the C1 and C2. It found out that C1 is closer to this, so X will become a part of this C1 cluster. Okay, again find out the distance of this with this. So it found out that this point is closer to this. Okay, so this becomes a part of C1 cluster. Find out the distance of this with this. So it found out that this point is closer to C2. So it becomes a part of this cluster. This is also closer to this. This become a part of this cluster. This is also closer to this. This become a part of this cluster. Okay. This is also suppose closer. So it become a part of this cluster. Okay. Also suppose this is closer. This become a part of this cluster. Okay. So depending upon which points will become a part of C1 and C2, the deciding matrix is what? Distance. If point is closer to C1, it will become a part of C1 cluster. If it is if it is closer to C2, this point will become a part of C2 cluster. But we will not stop here. No, we will not stop here. It's done. This first iteration only. This is first iteration because these two centroids were picked randomly. Okay, so now new centroids will be computed. Now new centroids will be computed. How? It will take x1, this point, and this point, and find out the mean of those. Okay, find out the mean of those, and that will form a new centroid. Okay, so whatever C1 points, whatever points are available in the C1 cluster, so it will take the mean of those points and find out the new cluster. Suppose that cluster is coming here this time, right? Suppose now it becomes your C1, it has gone, and again here also whatever points are forming cluster in the C2, their mean will be taken, and according to their mean, second point will be decided. Suppose that point is coming here. Suppose now C2, not this C2. Okay, so I can remove this. Where is eraser? This point has no meaning now. This point has no meaning now. Right? So new clusters are these. Again, the process will be repeated. What? Every point distance, this, every point distance will be computed with the C1. Every point distance will be computed with respect to C2. Okay, so every point, understand again, every point distance will computed with C1. Every point means 8 points are there, so all 8 point distance with the C1, all 8 point distance with the C2. And now again, what will happen? Shuffling will happen. Okay, or again clustering will happen depending upon now see, this C2 has become closer to X. So earlier this X was belonging to C1. Now it has come closer to C2. So now reshuffling will happen depending upon which point is closer to C1 or which point closer to C2. Okay, again shuffling will happen, and it may be possible this time this point belongs to this belongs to this, which is was borrowing earlier to this. Okay, this belongs to this belongs to this belongs to this, and this also belongs to this example, and this belongs to this, and this belongs to this. So two clusters again new have formed. This is second iteration. Okay, now what will happen again? What it will do? Whatever points are forming cluster in the C1 now, again those mean will be found out. So new centroid again will be found out. Again new centroid will be found out. Okay, and suppose this new centroid with respect to these 2 points are coming here, right? And again all the points which are forming the cluster in the C2, okay, those mean will be found out. And suppose this point is coming here, so new 2 points have come, new two centroids have come. Again same process will be repeated. The distance of all the 8 points with these centroids will be calculated. Okay, and now see everyone what will happen if again points, understand everyone, again distance will be calculated with respect to this point of every point and this point with respect to all point, right? And again reshuffling will happen. Okay, this process will continue again and again, again and again. And when it will stop, everyone, it will stop when, suppose at that time you created a centroid, find out a distance, cluster happens. Suppose it happened like this point and this point. Okay, in current iteration belongs to this cluster, right? Belongs to this cluster. Fine, done. So you computed the mean. Okay, and some mean came. Whatever mean came, according to that, a centroid is formed. Okay, a centroid is formed. This is the centroid. Again, these all points belong to this centroid. Okay, so again mean is computed, and suppose new centroid is coming here. Okay, now see everyone, if again distance is computed, and after computing the distance, we found out that there is no shuffling happen. These points belong earlier to this centroid only, and these points again belong to this centroid only, means shuffling has not happened. They have not moved any, no further point is moving from C2 to C1, or no point is moving from C2 to C2, means no shuffling is happening. At that time, you will stop. You will say my K means clustering has converged. Okay, when shuffling is stopped from C1 to C2 or C2 to C1, at that point we'll stop. You will say that my clustering algorithm has converged, and these are the clusters. Tell me everyone, is it okay? What is going to happen? Varun, Hardik,
Yes, sir.
ma'am. Okay, great. Great, right. It should be okay. Okay, simple algorithm, very simple algorithm. Okay, but point comes, how will you identify what the value of K should be chosen? Okay, what the value of K should be chosen? So what it does, there is an elbow method for the same. Actually, what we do, we compute within the cluster sum of square distance, within the cluster sum of square distance, known as WCSS. Okay, within the cluster. So what we do, suppose initially we'll choose K is equal to 1. Okay, when K is equal to 1, there will be only one cluster, and we will compute the distance of every point with that centroid that you have picked up. Okay, and what we will do, sum of square distance. Let me show you that, that will be easier for you. I have a PPT for the same. First of all, read the definition, what I said. Choose the number of K clusters, choose the number K of the clusters, select at random K points the centroid, not necessary from your data set as we pick, assign each data point to the closest centroid that from the K cluster, compute and place the new centroid of each cluster, reassign each data point to the new closest centroid. If any reassignment take place, go to stop 4, otherwise go to finish. Same thing is there. Okay, now what we are talking about, this is actually within the cluster sum of square distance. Within the cluster sum of square distance, what do you mean by that? Okay, suppose you pick any cluster. Suppose you choose this one. Let me pick this one. If it is option is there, let's see. Suppose you decided K is equal to 1. Okay, that cluster will be 1. So what you will do, and you pick this centroid, so you will compute the distance of every point. Okay, distance of every point with centroid, with your centroid, like this 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 this. And what you will do, you will do first of all square. Suppose this distance is d1, this distance is d2, this distance is d3, this distance is d4, this is d5, this is d6, this is d7, this is d8, and so on. So what you will do, you will do first of all compute the distance, and now you will do sum of square of distance, sum of square of distance. Okay, so what you will do, suppose distance is d1, so d1 square plus d2 square, this is d2 plus d3 square, okay, plus d4 square, sorry, d4 square plus d5 square, and so on. Okay, this is nothing but sum of square distance. Okay, sum of squared distance. And what you are doing, we are computing within the cluster. So this is known as within the cluster sum of square distance. Okay, you will compute this. Then you will choose cluster is equal to 2. C is equal to 2, right? This, like, let me clear this. Come on, like this. So you will choose among all the data points, you choose 2 clusters like this. So 2 clusters will be formed. Okay, when you have chosen 2 clusters, of course 2 centroid will be chosen. Okay, and now you will choose, again same process will be repeated. You will compute within the cluster sum of square distance. So distance of this with this with this with this with this, this with this with this, like this. And again same process will be repeated. What you will do, you will do the square sum of square of distance of everything. Suppose within this we have a d1 square, again d2 square, again d3 square, again d4 square, and so on, within one cluster. Done. This is in one cluster, cluster 1. Now you will repeat same process. You will within this cluster 2, because you've chosen K is equal to 2, you will compute the distance of every point with the chosen centroid. So this, every distance will be computed, every point with this. Okay, and again you will do the same process. Suppose distance are d1 square, d2 square, d3 square, d4 square, and so on. Okay, this will become your sum of square distance within the cluster 2, and finally you will sum these. Finally you will sum these. This is giving you sum of square distance of cluster 1. This is giving you sum of square of distance of cluster 2. Similarly, you will repeat the process to cluster number 3, 3 clusters, like this way. Okay, same data point is there. So again, what you will do? Again, you will compute same thing, everyone. You will compute distance of every point with the corresponding centroid, distance with corresponding centroid, distance with corresponding centroid, and for this, d1 square plus d2 square plus d3 square and so on. This also d1 square plus d2 square plus d3 square and so on. This also d1 square plus d2 square plus d3 square and so on. And finally, sum all of these. Okay, so we'll keep doing that, keep doing that, keep doing that, right? So sometime you will pick first of all k with only one cluster. You will compute WCS within the cluster sum of square distance. Then you will do k is equal to 2 within the cluster sum of square distance. Then you will compute k is equal to 3 within the cluster sum of square distance. And you will decide now this WCSS will decide the optimal value of k. You should not pick, okay, whichever will give me the minimum value, I will pick that. No, that is not the case. See, if I keep increasing these clusters, okay, how many points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30 points are there. Suppose I choose k is equal to 30. Okay, everyone. So how many clusters will be formed? 30. Right or wrong, everyone? If I choose k is equal to 30. So what will happen? Every point itself will form a cluster then. Right or wrong? Every point
Yes,
itself
sir.
will form what cluster? So distance will be what? Distance of it with itself will be what? 0.
0.
Right? 0. So that will give me minimum sum of square distance. But is it what you want when you want to pick every point as a one cluster? No, makes no sense then. Makes no sense then, right? So you have to choose the optimal value of WCSS. How will we pick that? Let me show you that. Okay, like this. Okay, so when you will pick different value of k, okay, this is the value of k, number of clusters that you want to pick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You will plot your WCSS here. Okay, so for k is equal to 1, of course there will be one centroid only, so all points will be far away. Your WCSS will be very large. When you pick k is equal to 2, it will decrease. Okay, k is equal to 3, it may, example, it is decreasing. See, so it decreased sharply, it further decreased sharply. But after this, if you notice, everyone, the decrement is not substantial. Slowly it is decreasing. Can you notice, everyone? Okay, this is decreasing sharply, this is also decreasing sharply, but after this point it is not decreasing that sharply. It is decreasing, but very slowly. Okay, so the point where your change becomes smaller, at this point, after this point, your change in the value of WSS is not substantial. You will stop here. This point will be known as your optimal point, and the graph that you are seeing is very much like our elbow only, right? This point will you will choose. This is your final, your optimal value of k. In this particular case, this value is the k is equal to 3. In this particular case, okay, so we'll plot this WCSS and we'll plot number of clusters, and we'll see wherever my elbow point is coming, this knee point is coming, okay, where the changes in the WSS become slower. That point will be considered as optimal number of clusters, and you automatically get an idea why it is known as elbow method, because it looks like our elbow only. Clear, everyone?
Yes, sir.
Okay, fine. Now let me move ahead and let's come to the implementation part quickly. Come again. Yeah, clear. Where it is, home page. Let me quickly create a new page. Okay, and let me import necessary libraries. So I'm gonna say I don't need this trouble anymore. Yeah. Import pandas as PD. Let me increase the font. Import pandas as PD. Import numpy as np, and I need matplotlib as well. Import matplotlib dot pyplot as plt. Okay, matplotlib.pyplot. Oh, sorry, spelling mistake. Pyplot as plt. Right, done. And now let me read the data set. A simple data set I've taken for the same purpose. This is my df is equal to pd dot read underscore CSV, and it is your mall customers.csv file. Okay, let me read it and let me check df.head. Okay, so actually this data set is given to us in which customer ID is mentioned, gender is mentioned, age is mentioned, annual income is mentioned, and spending score is mentioned. Actually, this is a data set of one of the store in New Zealand. Okay, what they do whenever somebody visit to their store, okay, they enter their information: what is your customer ID, what is your name, mail, what is your gender, age, what is your annual income, and depending upon how many times they have visited their store and do the shopping, they assign them a score between 1 and 100. Okay, this is the salary in the US dollars which has been mentioned here, and this is your thousands of US dollar, and this is your spending score. So what they want, only basis of this column, okay, divide them into the cluster segments. Okay, divide them into some clusters so that they want to launch some program for them. Okay, for this particular segment of customers, we will give them this particular concession, or we will give this particular thing for this. We will give them this particular promotion. Okay, so what they want, on the basis of these two columns only, on the basis of these two columns, they want to segment their customers. They want to divide them into different segments. Okay, on the basis of these two columns only, annual income and spending score value. Okay, this is what their requirement is. So only column for our chooses, our requirement is these two. Okay, first of all, let me check the shape as well. How many rows are there? Okay, 200 rows are there, but of our choice only these two columns are there. So what I can do, I can take only these two columns: df square bracket square bracket. First one is annual. Let me pick it from there. Okay, and second one is your this column. This is of my interest, right? Done. So this is my X. I can verify once again. X dot head. Perfect. Awesome. Right. Now let me move ahead. So only two columns are there. Both are numeric. Very good. So first of all, let me check what is the best possible value of key for this particular data. Okay, that is a better way. And let me see what is the best possible way. So I'm going to say using the elbow method. Come on. Using the elbow method to find best possible or optimal, that is better, find optimal value of k or clusters. Okay, so we'll plot our elbow plot, and from that you'll identify what is the number we are getting for this particular data set. Okay, so for the same purpose, let me import a library from sklearn dot cluster. Okay, import k means. Come on, take it. K means, yeah, done. Go ahead, now move ahead. And what I'm going to do, I'm going to create an empty list so that I can store the value of WCSS empty. And I'm going to run a loop for, suppose, I in range, and I want to generate the value of k to be from 1 to 10. So I'm going to mention 1, 11. Okay, I will pick the value of cluster to be from 1 to 10. Let's check. Colon. And then what I want to do, I want to use my a variable, or I'm gonna giving a name to an object. K means equals to this one. K means there. Okay, and within that I have to pass how many clusters I want. So n underscore, sorry, n underscore clusters, and how many clusters I want. I want to pick that clusters from this I. Automatically it should come at first instant only 1, at second instant 2, third instant 4, and we'll check is equal to I. Okay, this is what I put. And one more thing I want to put here, initialization method in it. It's actually important because what happened, remember how k-means work? Initially it picks the centroid to be randomly, so it may pick anywhere, and it may be possible your k-means clustering converge very, very, very slow, because initial point may be something like that. So to boost that process so that it converts fast, we have an initialization method here known as k-means plus plus. So just mention that k means just boost your convergence. Your convergence will become faster. Okay, your convergence will become faster with the help of k-means plus plus. Okay, and any random state you want to do is your choice. Random state, I am picking my favorite one, k-means 42, and done. So I have to specify what are my, how many clusters I want, what is my initialization method, and random state. Okay, and then I come here and then I fit k-means dot fit, on which what name you have given? You have given the name X. So just mention X here because we don't have a Y here, right? And now what I want, WCSS means your empty list dot append, because in this I want to append the value of WCSS. And how will I get? Once it is fitted, okay, you will get a parameter K means dot inertia. Okay, and this inertia is nothing but equivalent to your WSS. This is your WSS. So whatever this k-means will be fitted. After that, what is the WCSS coming? That WCSS will be appended in this. Okay, so the inertia, and let me put underscore. I think it is the one. Yeah, underscore. Okay, this is what I want. After doing this, I want to append. Okay, I want after do I want. Let me first of all do this thing, and then we will plot it. Let me just execute this first of all. Okay, let me check WCSS first of all. Okay, yeah, fine. I'm getting the 10 value. I should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Now I want to plot it. Okay, now I want to plot it. So to plot it, I'm going to mention plt.plot. Okay, and on x-axis, what I want to check the value of k that I put it 1 to 11. The same thing I will mention your range 1 to 11. This is my x coordinate. On the y coordinate, I want this WCSS list value. WCSS. Fine, and you want to give other thing, your choice. Example, plt dot title you want to put. Entirely your choice if you want to put. I'm going to say the elbow method. Suppose the elbow method. Okay, and I'm going to put plt dot x label. And x label is suppose your number of clusters. Number of clusters. And here I'm putting plt dot y label to be suppose WCSS. Yes, WCSS. And let me execute this. Can you check everyone? I'm getting a elbow method properly. Can you notice, please?
Yes, sir.
Right? And which you think is the optimal value? Somewhere around 5, right?
Five.
I'm somewhere around 5, right? So we one conclusion we made, the value of clusters, the optimal value of clusters equal to 5. Okay. So now what I have to do, we have to fit that. Very, very simple. We can fit it without any problems. So I'm going to say now. Okay, so fitting k means to the data set this time. Fitting k means to data set. Okay, so how will we fit? We are again we want to mention k means. Let me directly use that. That will be better. We have used the command here where it is. Let me pick it up. What is this? Okay, y label. Yeah, now fine. K means okay. Clusters, number of clusters. This time I will mention 5. Okay, initialization fine, everything is fine. And now what I want to do, fit. So I'm going to mention, I'll assign a variable as well. K means dot fit. And I also same want to predict the label as well. Actually, whenever you form the cluster, in every cluster, to every data point, it will assign some label. That means what? This particular data point belong to this cluster. So means how many clusters are going to form? 5 clusters are going to form. So it will create 5 labels. Okay, it will create 5 labels for every cluster. So all the data point which belong to one cluster, they will be assigned the same label. Understand what I'm saying, everyone? How many label it will create? Number of cluster have you
Five.
mentioned? So 5 cluster it will create. Every cluster will assign a unique label. Cluster 0, cluster 1, cluster 2, cluster 3. So all the data point which belong to example cluster 1 will be assigned same ID or will be assigned same label. Is it okay? right? Means it
Yes, sir.
belongs to
Clear.
that cluster, right? So k means dot fit, and for the predicting purpose also, I'm going to mention predict x. Okay, so on x, I want to fit and predict, and suppose this name I'm going to give y underscore k means, because you want to predict the level, what level it is doing. Okay, done. And now let me do one thing. Let me check first of all y underscore k means. Yes, can you observe it? 5 clusters that I find out 0, 1, 2, 3, and 4. Can you observe?
Yes, sir.
Right? And you can check the length of this will be equal to total data points in the your x. What was the size? 200. So it should be 200 only if we check its length. Len of y underscore k means. And we'll plot it. Don't worry. We'll plot it to see it better. Now, come on. What happened? K means here. Okay, 200 points. Okay, so every data point has been assigned some level depending on which cluster they belong to. Okay, and let's try to plot this time. So plotting, let me plot. Even we want to see the centroids. Even we can see the centroids as well. Okay, for example, our model name is what k means. So k means execute k means. Come on, k means dot. Okay, and what we want to see in the k means cluster centers. Okay, so we can see those centroids as well. Okay, x and y coordinates. Okay, as per the two parameters were there, na, remember? We have picked two parameters of x, annual income and spending score. So corresponding value it is showing the coordinates, x and y coordinates. 5 centroids are there, which are mentioned here, right? So let me come here and now let me try to plot it. I'm going to plot here a scatter plot. So I'm going to say plt dot scatter. Okay, and on the x-axis, I want to see all the clusters. So let me do one thing, and cluster I want to be specific as per the cluster. Means plot I want as per to specific to a cluster. So let me do one thing. I want to take x, okay, but only those point of the x where my y k means is equal to zero level, because we have 5 level. So I want to get only those point from the x which have yk means is equal to 0, means level of, sorry, y underscore k means, sorry, y underscore k means equals 0. Okay, it will give me only those points, and we can verify. If I pick it up here, we'll have limited number of points there. See, can you see everyone? Only 81 rows are visible here. That means 81 data points are belonging to what? Your level 0. Fine. Is it okay, everyone? What I'm doing here?
Yes, sir.
Right now you need your y coordinate. Okay, so y coordinate is what? Your this x means is what, but I want x axis on, I want to create x axis, right? So this is complete data point, but I want on the x axis, suppose this annual itself. So from this entire, I want to pick this one. Okay, so I can mention here in square bracket. Come on, take it directly. Not taking, no issue. Let me copy this. And let me show you first of all here what I will get. Then I will copy there. Can you see everyone? Only one point is coming. That is your annual income. And that actually I want to make it as x coordinate. We have to make one x1, one x2, right? 2 points are there. One is your annual income. So I want my like this. Annual income should be on this axis, and spending score should be on this axis. This is my requirement. Is it okay? What I'm trying to do?
Yes, sir.
Yeah, this is what I'm trying to do. That's why what I did first of all in the uh, complete data set, I filter out the data points which are corresponding to only label is equal to 0. Then I said, okay, I want to, from entire data set, I want to pick this column, and I will make this particular thing to be as my x value inside scatter plot, first argument. Okay, then I will mention my y argument. Now you can guess what everyone, what will be the y argument? Anyone tell me? For the same class, for the same class, what can we do? Just guess. This has become x-axis. So what will become y-axis?
Spending score.
Yeah, spending score. Exactly same. Means instead of this, what I have to do? Come here, come here, come here. What is the column name? spending score. Okay, so same things, exactly same thing. Instead of annual score, I have to mention here spending score. Okay, so this will give me the corresponding value. Okay, and this will become your y value. Fine, everyone, right? And I can copy this. So this is my x coordinate. This is my y coordinate. Okay, and even I can further specify size as well, because it is going to be several points. So let me mention, suppose size is a parameter here. I'm going to specify 100. Okay, the because it's scatter plot, so that bubble size I want to see, and color I want. So suppose I'm mentioning color is equal to, I want suppose red. Okay, and then comma, I can move ahead. Come on, come on, come on, come on. I need further. Color is red. It is awesome. I want to put a label as well. Suppose label is, this is my cluster one. Cluster one. Okay, and let me close and let me just check it. First of all, it is working or not, because same thing we have to do for every class. Just check it. That is fine. Awesome. We'll do with is doing what I want. Okay, so let me copy this, exit this, and small changes you have to make for every class. What? This time I want to pick label one here. Okay, and here I want to change the color. This time instead of red, I want suppose blue color. Okay, sorry, I have to make changes everywhere. What I did, just a second, start from the beginning. Here I want label one annual income perfect. Here I want label one annual income perfect. Here I want blue color, and here I want cluster two. Let me check these again. Let me execute this. Awesome. Yes, perfect. We are doing in the right direction. Again, put it. This month time I want the label to be true. Again, back again. Label to be true. Label two. Label two. Perfect. And color this time I want suppose cyan color or green color, whatever you want to put. Suppose green. And cluster, this is 3. Let me check again. Awesome. We are doing in a right direction. Perfect. Right. Again, fourth one. So let me come here. 3, 3. And this time color support, I want cyan cluster to be 4. Let me check once again. Awesome. Right. Last one. Yeah. Cluster to be 4. Okay. And here also cluster to be 4. Everything goes good. Let me change the color to be magenta, magenta, and cluster to be 5, right? And we can put some labels as well, because labels we have put, so awesome. We'll get a legend as well because we have put the label. That is the advantage of putting it. Come on here, and we can mention title. Suppose plt dot title. Or before doing that, let me just execute and check. That's what where the mistake is coming. Come on, come on, come on. Where the error is, it is showing error near this. Spelling is mistake, or what is the problem here? Magenta h is equal to 100, and last line it is saying everything is perfect. X and annual income y is square. And here also, let's start from this. K is equal to 4, y is equal to 4, spending over 1 to 100, s equal to 100. Is magenta. What the problem is? Everything is fine. Let me just a second. Let me comment this. Invalid syntax, it is saying. How it is possible? Just a second. Let me execute. Okay. Oh, sorry. Find the mistake. Yeah. Here, actually, parentheses is, I think, missed the parentheses. Now everything should be okay. Even this will work. Yeah, fine. So all 5 are here. And can you see the clusters clearly, everyone? Can you notify?
Yes, sir.
Yeah, how smartly it is able to identify all the clusters. Very quickly, smartly, you can identify the clusters, right? And same thing you can do with the images. What you do, just whatever cluster it has found, take the mean of the same, okay, and use that color. That will be better to represent, okay? And we can put the legend, what I was doing, we're putting the legend and the title as well. So pld.title, and I'm going to put my title supposed to be, uh, let's say, cluster of customers, okay? Cluster of customers. And I'm going to mention again plt dot x label. In the x label, we have annual, what we put in the x label, annual income, fine, copy, right? And y label, plt dot y label. And here I'm going to put spending score. Okay. And then I'm going to put plt dot legion. Yeah, fine. Can you check, everyone?
Yes, sir.
Right, easily it is able to identify all the clusters. So it is very, actually very famous algorithm which is available, very famous. But nowadays even people don't use it. There are better algorithm available than that. We have a fuzzy clustering algorithm. Okay, so fuzzy are there. Even the fuzzy, if you see, you will see at least, because I wrote a research paper on the same, and I reviewed more than 90 paper only on the fuzzy clustering, merely 90 papers. So several variant of every algorithm means clustering. In the clustering, it is a very decent research area. People are researching like a crazy this thing, everyone, and very easy if you people can work on the clustering. Awesome papers are there. Awesome papers are there. Even transactions paper you will get very easy if you try to do that. So awesome work is there. More than every means fuzzy clustering. If you see, there will be more than, if I'm correct, 50 variants of fuzzy clustering will be there. More than 50 variants of the fuzzy clustering will be there. Okay, even people are changing in the k-means clustering, using k-means clustering with something else, k-means clustering for something else. For this, and mostly people use this clustering for segmentation of images. Actually, it becomes very much powerful. For example, in case of your brain tumor somebody is having, or lung infection somebody is having, in that cases, if you can take those medical images and clearly segment, okay, where is the tumor is, what is the size of the tumor is, you can apply machine learning algorithm after doing the segmentation. Life is going to become very easy for you. Okay, this is your k means clustering algorithm. Okay, and I don't think so it is even needed. Let me delete this. Okay, everyone, that's first from my side. Actually, at 7:25 today, I have an urgent meeting today. So I will take early leave today. Is it fine? It's okay, everyone?
Yes, sir. It is fine.
Okay, actually, I have an urgent meeting today with the client. So unfortunately, last, it is the best. Not, it didn't happen in the regular classes. That's the best part, means last day was today. So I thought, okay, I know that I will be completed by that time, because that client is from the US. So he has again, his shift will start at that time. That's why we have to schedule in before 8. We have to complete it, and meeting will last for at least 25 to 30 minutes. So that's why. Okay, everyone, and thanks everyone for the participation. Okay, very much thank you, for especially Varun, Amrita ma'am, and Hardik, because of you people I enjoyed taking the classes. Otherwise, how many people are attending the classes. So
Yes, sir.
that is actually, that matters a lot, because if somebody is there and who is answering you, then actually it's the fun of teaching. When I'm delivering, nobody's answering. Trust me, it's biggest. I feel like what I'm doing. So because of you people, this journey began, and journey remain at least for these much days. I think it is our 42nd or 43rd session, if I'm correct.
43rd session, sir.
43rd session. So we took, ideally we planned for 6 weeks. So it is 6 week. If we take that way, 7 into 6. So 42 and 43. So this way it is 6 weeks. So I know that minimum 37, whenever I took this session, minimum 37 to 40 sessions, I always take. It goes that way, because I'm not that I will rush and no, I can't do that. Until I'm able to explain, I can't move ahead. This is my basic thing available. Okay, everyone. So I think I'm receiving a call. Everyone, I'm cutting it. Okay, everyone. Thank you. Thanks, everyone. Thanks for your time.
Okay, sir.
Bye
Thank you
bye.
for everything, sir.
Thanks, everyone.
Bye.
Thank you. Bye, Barun. Bye, Amrita, ma'am. Thank you.